Have you ever wondered how a simple PVC pipe is made? It starts as tiny plastic particles and ends as a perfectly round pipe with controlled diameter, wall thickness, and strength. But between these two stages is a fascinating engineering process involving mixing, extrusion, precision sizing, cooling, and testing. Let's go inside a PVC pipe factory and follow the complete journey from raw material to finished pipe. The process begins with PVC resin, usually supplied as a fine powder or compound. But PVC resin alone is not enough, depending on the pipe formulation and its required performance. Manufacturers combine it with stabilizers, lubricants, pigments, processing aids, and sometimes other modifiers. These ingredients are carefully selected because the final pipe needs the right processability, dimensional stability, and mechanical performance. The ingredients are then accurately weighed and mixed. Think of this like preparing a recipe, except this recipe is engineered for a specific pipe. High-speed mixers blend the PVC resin and additives into a uniform compound. Proper mixing is critical because uneven distribution can cause inconsistent processing and affect the properties of the finished pipe. The goal is a consistent material that can be processed reliably through the extrusion line. Once the compound is prepared, it is transferred to the extrusion line. The material enters the extruder through a hopper and reaches a rotating screw inside a heated barrel. This screw is much more than a conveyor. It transports the material forward while heat and mechanical energy bring it into the correct processing condition. Inside the extruder, the material passes through different processing zones. The screw conveys the compound while controlled barrel heating and mechanical energy gradually bring it into a uniform and processable state. Screw speed, temperature, pressure, throughput, and residence time all matter. If these parameters are not controlled properly, the pipe can develop dimensional instability, surface defects, or inconsistent properties. At the end of the extruder comes one of the most important components, the die. Instead of allowing the processed material to come out as a solid block, the die forces it around a central mandrel and forms a continuous hollow section. This is where the basic geometry of the pipe is created, including its circular shape, internal diameter, and wall thickness. The freshly extruded pipe is still hot and relatively soft, so simply forming it through the die is not enough to guarantee accurate dimensions. The pipe enters a vacuum calibration tank, where a sizing sleeve helps establish the required outside diameter. Vacuum draws the softened pipe against the calibration surface while water begins removing heat. This stage is critical for achieving consistent dimensions and maintaining a stable circular shape. After calibration, the pipe continues through cooling sections. Water removes heat from the PVC so the material becomes rigid enough to retain its shape. Cooling is not simply about making the pipe cold as quickly as possible. The process must be controlled so the pipe maintains its required dimensions and surface quality as it leaves the hot forming stage. Now we reach another critical control point, the haul-off unit. These powered rollers or belts continuously pull the pipe from the extrusion line at a controlled speed. The extrusion output and haul-off speed work together to influence how much material is distributed along each meter of pipe. In simple terms, the factory must coordinate material output with line speed to maintain consistent dimensions and wall thickness. Because extrusion is continuous, the pipe must eventually be divided into standard lengths. An automated cutting system uses the production line's length measurement and control system to cut the pipe accurately while maintaining continuous production. The result is a series of uniform pipe sections ready for the next operation. A pipe is not useful in a pipeline unless individual lengths can be connected. That's why many PVC pipe systems are manufactured with a socket or bell at one end. The pipe end is heated and formed into a controlled socket shape. Depending on the product and application, the joint may use a sealing ring, gasket, solvent cement, or another specified connection system. The socket must be accurately formed because the joint is just as important as the pipe itself. Now comes the question every engineer asks. Does the finished pipe actually meet the required specification? Quality control begins with dimensional checks. Technicians measure the outside diameter, wall thickness, length, and other required dimensions. These measurements are not cosmetic. Accurate dimensions are essential for proper jointing, fitting compatibility, and consistent performance in the pipeline. For pressure-rated PVC pipes, dimensional checks are not enough. The pipe may also undergo hydrostatic pressure testing according to the applicable product standard. The pipe is filled with water, and controlled pressure is applied for the specified test condition. The purpose is to verify that the pipe can withstand the required internal pressure without unacceptable failure or leakage. Depending on the product standard, additional tests may examine properties such as impact resistance and other performance characteristics. This matters because pipes do not live inside a laboratory. They are transported, handled, installed, and sometimes exposed to unexpected loads. Factory testing helps verify that the manufactured product meets the requirements specified for its intended application. Before leaving the factory, the pipe is normally marked with important identification information required by the applicable standard and manufacturer. Depending on the product, this can include the manufacturer, nominal size, standard reference, pressure or class information, and traceability details. That marking allows the product to be identified and linked back to its manufacturing information. Finally, the finished pipes are inspected, bundled, and prepared for storage and transportation. Proper handling is important because even a correctly manufactured pipe can be damaged by careless loading, sharp impacts, or unsuitable storage conditions. Manufacturing quality is only the beginning. The pipe must also be transported, installed, and operated correctly. So the next time you see a PVC pipe, remember the engineering behind it. PVC resin is mixed, extruded, shaped, vacuum calibrated, cooled, cut, jointed, tested, and marked for traceability. What looks like a simple plastic pipe is actually the result of material science, mechanical engineering, process control, and quality assurance.